Last week we did latest sprinkler news. So I looked at some of the new standards that were coming out, some of the new products to show you, and some latest some fires that happened recently, sort of discussing where sprinklers weren't installed and there probably should have been. I gave the example of a primary school that burnt down sadly last month, which didn't have sprinklers installed despite the school spending money on refurbishment works, but so that didn't include a sprinkler system, unfortunately. And there was actually the hot works involved in some of the improvements that they were doing that they reckon actually caused the fire in the first place. So, it was a case that that they were trying to make things better, and of course, ended up making things worse. Today we're going to be looking at the different types of sprinkler system. So the one that people are most familiar with is the wet system, which we've talked about in previous episodes. Whenever I've been sort of giving examples of how things work or what things do, that's always been in a kind of wet context. But there are other types of sprinkler system. You can see them on the screen there: dry, pre-action, Deluge, MJC, and Gemini. There's also a bonus one which I haven't actually put on the list there. It's called an alternate system. So I'll go through that one as well. Just making you aware of the different types of sprinkler system and how they operate. So we'll be getting on with that in a few minutes' time. Just going to put the Facebook stream on now. It's good. It's working. Yeah, I can see myself sort of looking back in time a few seconds on the Facebook stream, so that's good. It's all working. Just another minute, I think, till 10 o'clock, and then we will make a start. As I said before, be really good if you could sort of spread the word about Sprinkler Talk in your social media, LinkedIn, your colleagues, for example. You just let them know what's going on. And also just a reminder that these presentations are being recorded and will be available on our YouTube channel, Project Fire, and also on our website as well. Our website is www.projectfire.co.uk or projectfireproducts.co.uk. Both will kind of get you to the same place. So as I mentioned, today we're looking at the different types of sprinkler system. So let's make a start. Okay, so I've shown you this diagram, this kind of illustration of how a sprinkler system works, and I've shown it to you a couple of times already. So I'm not going to go through it again, but just as a reminder, this is a wet sprinkler system. So it's called wet because we've got water in the pipes. So all of it is it's got water in, and the water is held under pressure, and it's that water pressure which means that the water can get tackling the fire straight away, because the pressure is sufficient to kind of push onto the deflector and create this fine spray, which is created by the water hitting the deflector on the sprinkler head itself. And it's that pressure within the pipe which is holding the alarm valve closed. So when that pressure reduces because water is coming out, then that triggers the alarm valve to open, and then other things to happen to kind of come into play to bring more water in and to set off more alarms. So the difference between these different types of sprinkler systems is really mainly down to the alarm valve. So number 4. So is it a wet alarm valve, a dry alarm valve, a pre-action alarm valve? That's the key thing here. Anything kind of below the alarm valve is really the water supply. So that can be whatever it is. Say, generally speaking, a pump and tank is typically what we use, but there are other options for water supplies, which I will go through in more depth in future presentations. But yeah, all of that is kind of secondary, really. That's all. Whatever you want it to be, the water supply is. And then when you get to number 4, the alarm valve, that's when you start to change into the different types. You can mix and match. I mean, that's one thing that I need to say. So you might, generally speaking, you only have one water supply, although it might be a duplicate supply. So you may have 2, but generally just have one. Number 4 is the start of a sprinkler installation. Although, I know that in different countries they're going to use different terminologies, but yeah, in the UK we would call that the installation. So another name for the alarm valve is the installation control valve. So number 4 marks the start of installation. You could have multiple installations, and they could all be wet, or you could have 4 wet, 1 dry. You could have 2 wet, 2 dry, and 1 pre-action. So you can mix and match the alarm valves to suit the particular application, this particular building that you've got. And really, you could have as many installations as you like. Generally speaking, you will only have as many as you need, because there's no kind of benefit to having additional ones, really. So yeah, you just have as many as you need. And again, there are limitations in terms of the size of each installation, but yeah, I will cover that in another presentation. So yeah, that's just a reminder really of our wet system. And this diagram here shows the alarm valve, the wet alarm valve, in a bit more detail, and we can see some of the other components here listed. So I've talked about how the alarm valve opens when the water pressure drops, and when I talk about opening, I'm talking about this clack. Other people call it a clapper. I think there are probably other names for it as well. But yeah, that's shown in the open position at the moment. Okay, so water is flowing from below the alarm valve up and through to feed the sprinkler heads. You can see, hopefully you can see my mouse here, but you can see this little opening at the side here. So that is called the annular groove. So when the clack is open, then water will exit down through here, and that is when what triggers the pressure switch. That's what triggers the water motor alarm gong, and then that water will then escape through the drip union. So once the alarm valve is closed again, then that water will sort of relieve itself through the drip union. On this sort of 2D diagram, it looks like the annular groove is just like in one place. Generally, it goes all the way around the kind of the diameter of the clack, because the clack, remember, is a circle, it's a disc. So yeah, the groove goes all the way round that circle to allow water to come out of it. And I think that's partly due to stop it getting blocked. If you just have one hole, then a little bit of corrosion, etc., can block it up. But yeah, you've got a large kind of area to draw water from. The pressure gauges in a sprinkler system, there are three key pressure gauges. They're called the A, B, and C gauge. So the A gauge is over on your water supplies on your pump line. The B gauge is immediately below the alarm valve, and the C gauge is immediately above. So obviously, when the clack is closed, those pressures could be different. The C gauge could be at a higher pressure than the B gauge, but generally speaking, they're going to be about the same. So that's say a little bit more detail about the alarm valve. There will be some variation, particularly to manufacturers. They'll have their trim set out slightly differently. So this trim here is shown all on the right-hand side. Some manufacturers have got a bit on the left and a bit on the right. You could use a flow switch instead of a pressure switch as your kind of trigger for saying that the alarm valve is open. What else is different? Oh yeah, this one is showing a combined test and drain connection, which I haven't actually labelled, which is a mistake on my part really. So again, hopefully you can see by mouse this piece here out the right hand side of the alarm valve. That's sort of the main area for draining water out of the installation. And you can see we've got two handles. We've got a large handle and a small handle. The small handle is for testing purposes. That is when you want to draw off a controlled amount of water to simulate one sprinkler head in operation. And you would do that on a weekly basis. So when you open that valve, the reducing pressure above, the clack lifts, and you check everything's working. If you just wanted to drain the water out as quickly as possible, then you would use the large handle, and that would obviously be a full bore drain, large bore to kind of just get rid of the water within that installation. And obviously, before you do that, you would close the isolation valve below. Generally, we'd have an isolation valve above and below. You can see this one shown here with a gate valve. You can also get these kind of I think O, S, and Y valves. Really big, heavy valves. Or you could use a butterfly valve. Again, this one's shown with a flanged trim, but it could be a groove trim for the alarm valve. So there are going to be some differences, but that's a good kind of starting point anyway. So a few points about a wet system. So say most sprinkler systems are of the wet type. It's the default type. If there's no reason to choose something else, then we choose wet because they're the most simple, they're the most reliable, and they're the best in terms of getting the water on the fire as quickly as possible. So that's why, for life safety, we want to use a wet system where possible. So, say if it's not possible, then we can use something else. But life safety systems are going to be using a wet system the vast majority of the time. It's permanently charged with water, as I mentioned. That's kind of what makes it wet. Any risk of frost damage needs to be addressed. So. Obviously, if the temperature is going to drop to a point where we might have water freezing, that is definitely bad news. The ice is sort of takes up more space than water, so we're going to potentially damage the pipes. We're going to damage the sprinkler heads, and also we're going to create blockages within the pipe, so the water can't actually get to where it needs to be. So. Ice within our wet sprinkler system is a bit of a no-no. We don't want that. So you can address that. You can use trace heating. which is a like a little electrical cable which runs over the pipe just to give a base amount of heat to stop it freezing. We can use lagging, so we can kind of wrap the pipes up in blanket basically to stop it from freezing. But over a large area, that becomes a little bit expensive and impractical. But that's that's two things we can do to address the danger of frost. For underground pipes, obviously we're generally okay if we bury them deep enough. And the same again, in very extreme cases, if the temperature is going to get to a point where the water in the pipe is likely to boil, to get approaching 100 degrees, then again we don't want a wet system. But that's quite a specialist area really. Grid and loop systems must be wet type, so just taking that from our code standards. Grid and loop refer to the way in which the pipes are laid out. So grid is self-explanatory really, so all of the pipes that are interconnecting. That's got some benefits and disadvantages, which I won't go into right now. And also a loop system is again self-explanatory. It's when it's got connected around the back and around the front. So both of those will have to be a wet design. Okay, so that's wet. We've done that one. So what about dry? So dry is called dry because the pipes are dry. So in the wet, they were permanently charged with water, and now here we're using air. It could be some other kind of gas. It could be nitrogen, for example, within the pipes. But typically, it's just ordinary air, which is held at a pressure. So our alarm valve now is the sort of the boundary between the water and the air. So the air is on top of the alarm valve, the water is below the alarm valve, ready to enter the system in order to provide the water to the heads. So in this instance here, say it is the air pressure which is holding the alarm valve closed. Now there is some sort of physics here to do with the fact that because which way around is it now? Yeah, air can be compressed, can't it? But water can't be quite so much. So we don't need as much air pressure than water pressure to hold the alarm valve closed. So the actual amount of pressure that we'd read on our C gauge in this case, which is air pressure, is going to be lower than we would have for water. So maybe 2 bar of air, 3 bar of air, something like that. We wouldn't be getting up to 10 bar of air pressure. Say it's not required, and also it's dangerous because that air is quite explosive. If there is a leak, if something breaks, it's going to go bang because of that air being compressed inside it like a balloon. So that air pressure that's holding the alarm valve closed. So when there's a fire, the sprinkler heads are going to operate as normal, so that there's no real difference between a dry sprinkler head and a wet sprinkler head. They don't really exist. You're just using sprinkler heads, so they're going to operate in exactly the same way. But of course, instead of water coming out the head, we get air coming out the head, and that air pressure is going to drop within the pipes. And when that air pressure drops, the alarm valve opens and the water comes in. The air is maintained. So again, with the wet system, that's something that I didn't mention actually about a jockey pump. So on a wet system, we use a jockey pump to maintain pressure within the pipe above the alarm valve and below, to be honest. But yeah, mainly it's there for the pipe work above. We're going to get small leaks, and because say water is not. It doesn't compress very easily. A small leak causes quite a large drop in pressure. So we have that jockey pump there just to top it up. Obviously, if you've got a large leak, then you're going to want to investigate that. And a large leak may cause the alarm valve to trip. But the idea is that really small leaks on the system will just be topped up by the jockey pump and will not trigger the alarm valve. Same with the dry system, so we have an air compressor there to act like a jockey pump and just top up the system air pressure. keep that right. However, again, in the UK standards, we have a maximum of 60 seconds water delivery time. So that is the time from the sprinkler heads operating for water to actually be discharged. So in order to meet that 60 seconds, it kind of restricts the amount of volume of the pipe work and also the area. If the head is right next to the alarm valve, then you've got a good chance of getting the water there pretty soon. But if the head is at the end of it's the furthest from the alarm valve, and of course we would always be looking at the worst case scenario. So we would calculate it based on the heads furthest from the alarm valve. Then meeting that 60 seconds then becomes problematic, which means we've got to make the system quite small. There are technology we can use to help, accelerators and exhausters, and they work to the accelerators will sense this pressure drop, and then they will help to expel the air. Similarly with an exhauster, it's there to pull the air out. So once you kind of figured out, okay, we've got an activation, then we want the air out as soon as possible. So we stop the air compressor, and we open up another valve, and we just get rid of the air as quickly as possible. We don't wait for it to kind of come out the heads. We then pull it out from the side. So that's all there to kind of meet this 60-second deadline. Dry systems are there, typically used where wet is unsuitable due to temperature. So if you've got an open-sided car park, for example, or a cold store, or some sort of unheated warehouse area, then a dry system is used in that. So there is more for industrial uses, and yes, some commercial as well. So question, sorry, about where the air compressor is. So that's on this line here. So you can see that this line here, we've got our pressure switch. So that pressure switch there is going to sense drop in air pressure, but if this line sort of continues, that'll be connected to the air compressor, and it will be sort of pushing in air here. So again, you've got sort of two kind of systems here. You've got one which is sort of set a bit higher. So let's say that the air pressure is supposed to be 3 bar within the system. So when it gets to kind of 2.5, the air compressor will kick in and drop back up to 3. If the air pressure drops below that, it keeps, because you've got a sprinkler head opening, again, the air compressor is sized like a jockey pump. So if a sprinkler head is activated, the jockey pump, shouldn't be powerful enough to pump more air in. So the jockey pump the air compressor is set at 2.5 bar. When it gets to 2, then that pressure switch is going to say, whoa, we've got an activation, stop the air compressor, and start to pull the air out if that system is in place. This here is an alternate alarm valve, and it's a bit of an ugly brute, isn't it? So here we've got a wet and a dry alarm valve, and they're kind of stacked one on top of each other. So the idea here is that in the summer months, in the warmer months, we can set it on wet, and when it gets cold, we can swap it over and put it on dry instead. So the idea is we kind of get in the best of both worlds. The reality is that that they're unreliable, mainly down to corrosion. We'll talk about this in future presentations, but sprinkler pipe work is generally just ordinary steel pipe. It will rust, it will corrode, and going from wet to dry to wet to dry to wet to dry, that's the way to speed up corrosion within the pipes. These alternate systems just falling apart really after just a few years of service. We no longer use alternate systems. If there are any out there in the field, then we tend to set them on dry and leave them alone, which kind of makes logical sense really to me. if the system is in the winter, if it's suitable to have it on dry, if that's suitable for the risk and the application, then why isn't it suitable during the summer? So yeah, if dry is good, then let's just leave it on dry. Right, pre-action system, starting to get a bit more interesting, these systems now. So, and this is why I said, a wet system is preferred, because it's the most reliable. When I said reliable, I suppose I meant simple, i.e. the more stuff you put in, the more valves and controls and, obviously the more things you've got, the more likelihood is something's going to go wrong. So yeah, the simpler the better, really. So yeah, a wet system is the most simple design, and therefore arguably it's the most reliable. Right, a pre-action system then. So that is it's a dry-based system. So you can see we've got air in the pipes instead of water. But the alarm valve, the clack, is not triggered. It's not triggered automatically. Okay, so we now have this. Again, if you can see on the diagram, we now have this kind of ram that's holding the alarm valve closed. So it is not just the drop in air pressure which is going to cause that to open. You can see the other thing that we've got here is we've got the fire detection system. So we now have smoke detectors or heat detectors, but commonly smoke detectors. They're linked into some kind of fire alarm panel, and that fire alarm panel is linked to a solenoid valve as part of the pre-action system. Now, there are different ways which you can set up a pre-action system. They're called type 1 and type 2, or type A and type B. So I'll explain briefly what each one of them does. The most common type is a type A or type 1, which is like a double knock system. That's the kind of the idea behind them. We're protecting an area where we really don't want accidental water discharge, and we want to put some extra precautions in place. So maybe it's some kind of art storage, for example. So an accidental water release would cause millions of pounds worth of damage. We do want to protect it from a fire. Let's say it's a kind of museum storage. So we don't want a fire, because that's going to damage a massive warehouse full of storage. But on the other hand, we don't want accidental water discharge either. So we could use a pre-action system. And what that means is that we've got two systems which need to activate in order for water to be discharged. So we need the sprinklers to activate, and we need the fire alarm to activate. So we need smoke from the smoke detectors and water, and the sprinklers to activate at the same time. Okay, so if the fire detection system operates first, which is generally what's going to happen, smoke detectors are set to be more sensitive, so they're going to go off first, and that's going to kind of partly open the mechanism to open the ram, but it won't open all the way until the sprinklers are operated, the air pressure goes out, and that kind of opens the other part of the ram. Once you've got both of those things, the alarm valve will open and the water will be discharged. If the sprinklers go off first, let's say that the sprinkler head is damaged by somebody, and the air comes out, yes, that will open, say, kind of half of the mechanism, but that's it. Nothing else will happen. No water will be discharged. You'll obviously get an alarm to say that it's partly open. The air pressure is gone from the system. So that will obviously need to be investigated. The sprinkler head replaced, the system reset. But yeah, there's no water damage. There's kind of no harm done really to what we're protecting. So it doesn't matter which one goes first. You need both of them to operate in order for water to be discharged out of the heads. The other way that you can configure it is that when you get the smoke signal, the air can be sucked out of the heads of the pipework. Sorry, the air can be sucked out of the pipework and the water can go in, and so it's ready to operate like a wet system when the sprinkler heads operate. So on the basis that the smoke detectors are more sensitive than the sprinkler system, okay, we can use the smoke detectors like an early warning system, where we can then set the sprinklers onto wet rather than dry, ready for their operation. In that instance, if the sprinkler heads don't operate, okay, so it's a false alarm, then the system can be drained down again and the system reset. There's still no harm done. There's still no water being discharged in that instance, but it is a lot more faff to to get the water out and to reset it all back to where it was. But again, horses for courses. There are two main ways in which you can set up your pre-action system. But say that the key thing here is we are bringing fire detection systems, linking it in with the sprinklers. The other systems that are completely separate. There may be signals going from one to the other, but they are electronic signals. There's no kind of mechanical link between the two. Right, finally, we're on to deluge systems. So a deluge system kind of is the one which the kind of movie franchise pushes, really. In the movies, all sprinkler systems are deluge systems rather than wet systems, it seems. Because in a deluge system, that there's no, yes, there's air in the pipes, but yeah, it's atmospheric air, i.e. it's not pressurized. So the water's held back at the alarm valve, and all of the heads are open. Okay, so when the alarm valve is triggered, then in this instance, all the water is going to come out of all the heads at the same time. Okay, so because of that, the deluge system is going to be fairly small in size, because there's obviously a limit to how many heads we can have operating at the same time, whilst giving the correct pressure and the correct flow to give the effective operation. So deluge systems, say, are generally quite small, and so they might be part of a larger sprinkler system. So you maybe have got this sort of factory-based, which is protected via a dry system, for example. And in one area of this factory, we've got a particularly high hazard operation. We're doing hot works with a flammable material. We can then use a deluge system to protect that one area. To say the idea being that you're kind of going to hit the fire hard with lots of water straight away. So the deluge system is activated generally by a fire detection system, but it could also be kind of a manual push button release. If you see trouble, push this button, and that will set off the deluge system. And again, it's done via electrical signals operating solenoid valves, which will then open the alarm valve and let the water in. I think that's all I need to say about that. So yeah, in the movies, when they've got, I've seen them when they've got like a school building, and one of the kids sets off a sprinkler head, and they all start going. A deluge system. Imagine the water supply and the pumps required to protect a whole school where every single head is going off at once. It would only last a couple of seconds, wouldn't it? You'd run out of water very, very quickly. So yeah, that's a deluge system where it kind of does work like the movies suggest. Okay, a couple of other things. Multi-jet control. So this isn't a sprinkler system type as such, but it can be used to almost like a tail end deluge system or tail end dry system. So you've got an ordinary wet system, and then at some point you're going to install one of these, and then you can have more pipe, more heads, and that's a dry thing. And you can install open sprinkler heads on the other side of these valves here, because that's I call them valves because that's essentially what they're doing. They are basically automatically operated valves, so they are normally closed, and they're held closed via the generally again via the sprinkler bulb. So when the heat from the fire breaks that glass bulb, it opens the valve and lets water flow in and then out of the already open sprinkler heads. So like I say, that they're used for creating a sort of a tail end dry system or tail end deluge system. So yeah, maybe you've got little patches where you want to you don't want sprinklers sort of inside of the room. Say you could have a multi-jet control immediately outside of the room, and then when that opens, the heads inside will operate. And again, they come in a variety of shapes and sizes, different outlets. Also, I want to point out this product here, which is called Gemini. So this is like a pre-action sprinkler system based on a single unit. So you can see we've got two sprinkler heads, and anyone that's kind of done any kind of sprinkler design would immediately maybe frown and say, hang about, those heads are too close together. And indeed, they are. However, only one sprinkler head actually discharges water. It's a very clever device. It's all mechanical in the way it works. It's electrically monitored, but it is all mechanical in the way that it operates. And what it allows you to do is create a double knock protection whilst connecting off standard wet pipe. So again, I'm not going to go into it in great deal now, but if that's of interest to you for protecting small areas of a building, so server rooms, for example, in high-rise office blocks is a really good application for this. We've got a standard wet system, we've got a small server room, we can just connect off into a couple of these Gemini heads, and then we've got double knock protection within that server room, but without having to have a full pre-action system to actually to run to achieve that. So yeah, so if you're interested about that, have a look on our website, contact me, contact Project Fire, and ask about our Gemini product. Yeah. Okay, so that's it for today. So next week we're going to be talking about life safety. So essentially we're looking at Annex. What Annex it is? Annex F, isn't it? Yeah, Annex F of BS 12845. That's kind of my key document. Life safety in different countries, different standards will vary, but the general principles will be the same in terms of improving the reliability and availability of the sprinkler system. That's kind of what it's all about. So yeah, next week we're going to be talking about life safety. As always, I'll just have a check on Blue Jeans and on Facebook for any questions regarding the different types of sprinkler systems. Okay, so yeah, I hope you found that useful as a sort of a quick overview of the different types that are available. I say if there are different manufacturers of alarm valves, and if you ask them, then they can send you more information. They may have videos, they may have their own sort of diagrams and literature about how they work, the different types that they have available. And so yeah, I would just encourage you to contact them as well. I know that Viking, for example, have got their own. They've got a kind of training centre where they can kind of show you around and show you the different valves. And other companies, Reliable, Rapid Drop, for example, Tyco, they've all got their own facilities in order to help people that are interested in their alarm valves to show them all about it. Okay, so yeah, thanks a lot, and hope you have a good day. Hope you have a good afternoon or evening, depending on where you are in the world. And I'll see you next week. Bye-bye.